So, how do neural networks fit into reinforcement learning? Well, remember how neural networks are touted as universal function approximators? What if we use neural networks to represent our value functions? Would that work? Let's take a closer look. A state value function maps any state S to a real number, which indicates how valuable that state is according to the current policy pi. If we used a neural network to approximate this function, then the input would need to be fed in as a vector. Now, we already know how to do this using a feature transformation X. Okay, now the input can progress through the network, and if it is designed to output a single real number, that is our value as estimated by the network. Great! This seems to fall in place with the general idea of approximating a value function with the weights of the neural network forming the parameter vector W. The question is, how do we learn these parameters? If we have a reference or target we're trying to reach, for example v pi provided by some oracle, we can use the squared difference between the estimated and target value as our error or loss. Then we can backpropagate it through the network, adjusting weights along the way to minimize loss. One popular method for adjusting weights is gradient descent, where we iteratively change weights a small step away from the direction of error. In order to apply gradient descent, we need to know the derivative of the value function represented by the network with respect to its weights. Now, this can become very complex, especially for networks with deep architectures. But we have pretty efficient algorithms implemented in libraries like TensorFlow, Theano, and MXNet to train neural nets for us. All we need is a way to figure out the loss, and that's where our knowledge of reinforcement learning comes in. At this point, let's also consider the action value function Q. The update rule looks very similar to what we had for the state value function V. But we have the same problem here. For most practical problems, there is no oracle to tell us what the correct value function v pi or q pi should be. We need to use a more realistic target, one that is based on our interactions with the environment. This is where reinforcement learning fundamentally differs from supervised learning. Next, we'll look at some strategies we can apply to find suitable targets to use in place of the true value functions in these equations.